Starting. This stream is starting and starting and starting. Righty then. All right, and now we have the spinny wheel, and we have molecular mechanical computing systems. Stream go, which means I should probably put this onto the Twitters. Okay. And looking at my YouTube page, we have Live Now, Part 1. It seems to be a thing. Excellent. This seems to be a thing. So, welcome, ladies and gentlemen, to Let's Scientifically Replicate Molecular Mechanical Computing Systems in Scrap Mechanic, Part 1. This is a paper by Merkel, Freitas, Hogg, Moore, Moses, and Riley, published in 2016, and I'm just going to zoom in. It's published April 2016. This is actually a really exciting paper, and the reason why I'm doing this is because both as a way of exploring the implications of this and to show that this theoretical paper is possible, and to demonstrate a computing framework in scrap mechanic, because it's useful to have a coherent system of logic gates in the game, and hopefully that's going to be useful to other people as well. And so that's the introduction. I did try this last night, but I managed to delete the stream, so such a shame that you won't see me, struggle to learn the interface of scrap mechanic and try to find a piece of level ground. We'll start with the plan. And so this is the working thing. Let's talk about replication, right? For replication to be successful, I need to demonstrate a circuit in scrap mechanic using scrap mechanic's basic stuff. I then need to replicate that circuit using Merkel's mechanical computing and get it to do the same thing. Now, obviously, starting this out is going to be very, very fiddly, but the basic plan is step 1, I'm going to get a door to work using an XOR circuit. So we have input 1, input 2, and output. If they're both on, door is closed. If one is on, door is open. And if they're both off, door is closed. So white is off, apparently. Black is on, door is open. Off, door is closed. Or off, door is closed. So this is how I do it in the normal scrappy mechanic-y way. As my chair creaks. This one, and it rotates it 30 degrees, and the black circuit rotates the top one 60 degrees. And so therefore, if they're both off, the sensor isn't covered this way. And if they're both on, the sensor isn't covered this way. This, on the other hand, is what I started with yesterday. And this is me building a 4-bar linkage. Specifically, we're computing with 2 parts. We're computing with a 4-bar linkage, and we are computing with a lock. And so yesterday was me spending an hour getting this thing to work. And so this is one state, and this is the other state, and they are stable in this thing. What I realized was I can't do the full system because of the force due to gravity. So I had to restart, and then I realized that this work surface that I so quaintly alluded to Doc Smith with wasn't very good because I couldn't lift it up. So that's the plan for tonight. The objective is to probably not going to get. The objective tonight is to demonstrate a horizontal 4-bar linkage and a lock. I want to build figure 5 being able to demonstrate the lock tonight. That's my objective. And if we're very lucky getting it to open a door in a very simple way, well, you'll see. All right, so we begin. And the trick, by the way, to this is that this is part of the structure and is anchored by this little bit. So I'll reproduce it tonight, and it should be fine. For all 0 of my current viewers. Okay, how do I do this? Shift. All right, so we go. Now, before I do that, I need to send. I need to send this person this thing because I said I would. Copy. I don't want to start up Gmail. Fine. While Gmail's loading. So this is definitely in the extremely large variant. Oops. Okay, done. Oh, I hope the computer doesn't bleep. You know, I'm going to just close Gmail. Just close Gmail. Right. Yay, talk about professionalism. So, this is built at a very large scale. Optimization will come after it works. The process of proofing, 1, 2, 3, 4, 5, 6, 7. The process of proofing is the first thing. And so this is a free floating bearing, right? Free floating bearing that can make this. And so after I release it from the lift, does that work? Excellent. After I release it from the lift, it'll do its thing. So what I learned last night is that while this is the pure thing, I need 2 resetters so that it can reliably go into a 0-0 state. Now, clearly, this is not an important. Sure, fine. This is not a part of the design. This is a engineering externality, for lack of a better term. But it's an important externality, and we shouldn't forget it. So, button goes there. This goes there, this goes there, and we want to rotate towards the red, towards the red in 180 degrees, and actually no, in 90 degrees, because this is going to be in lay flat mode, 90 and 90. So hypothesis is that this will so if I delete the lift, it goes flat, and I can go wonk, and wonk, and then when I'm unhappy with the state, I can then lock it back into place. Great! That is precisely what I wanted to have happen. Now, what we're learning is we need a Nope. 2, 3. So we need this to have a base. 2, 3. the lift. Alright, so it's on its thing and it's resettable. Lock, unlock, wonk, wonk. Alright, and then we put it back on the lift. And this is what I left out last night. So, plonk. Now, we have two gates, and the dimensions are right now completely arbitrary. We can see, is the 2 cool yet? No, it's not. We can see optimization comes after it works. So this has a length of 7. 1, 2, 3, 4, 5, 6, 7. I'm going to put 14 between each of the center nodes. 1, 2, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I'm not doing this for any particular reason, save a not notional desire for symmetry. Again, after it works, we'll make it better. Eep, 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 eep. And I'm sure that I'll come up with better stops for the thing, and so on and so forth. Like, so this is, I mean, I would do 4, 5, 6, 7. I would invite any stream viewers to contribute comments about ways of improving this, but I would actually rather see you take this idea and run with it yourselves. Now, the cool thing about this is because all of these are free floating and locked, I only need one resetter. And this is why I needed that, because previously, when this was attached to the ground, I couldn't do this. So, hypothesis, this is bistable in such a way that it is, it's static in both dimensions, and can usefully represent on or off. So, wonk, state 1, I was not expecting that. And so, the annoying thing is, if violated the first rule, after every step in this thing, you must test. You have to, because the principle is that I need to build this as growing from a single point, right? I can't, so, okay. Thing goes up on the lift, right? And so I can't take over the world. Thing goes down on the lift. In order to get this to work in Scrap Mechanic in this version, and we're playing an alpha version, and I would be, as the English say, chuffed if the developers listened to any of this with an eye towards. So, because I've got this working, I need to extend it from here 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Anyone want to bet? Anyone want to bet? Where's the markers? There are no markers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope. Come on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so you need to do this from this because the game doesn't allow loops, and so we need to cheat in the loops. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And so, as you can see, we're rebuilding that, but backwards, right? So that goes 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3, and I mean, technically, you don't even need this, right? So just 2 and does that look the same? It does look the same. 1, 2, and then 1, 2. Okay. So just so that only necessary things are here. We have this and we have this. Now, this is free floating. I hear someone say, this couldn't possibly work. Correct. But the trick is that this 1, 2 is locked, and so this is an essential component of the scrap mechanic thing, because by coupling this to the base, which is why I'm using 2 different materials, by the way. By coupling this to the base, using these, and I'm binders, right? So and then no. Right? Anyone watching? No one's watching. That's fine. So, why am I doing this on YouTube? Well, this is very much an engineer's journal, in the sense that I'd very much like to get a publication out of this someday. How do I remove this from the lift? Like so. So my intention is to publicize this on YouTube, and then use this as the basis of a journal. Voila. So who am I? I built apps for archaeologists. I work at a university in Sydney. Background is in information technology. My BS and MS are in infotech. My PhD is in the philosophy of data. Of note, I'm going to be using the circuits that I learned and then didn't really think about 14 years ago in my freshman class on computer hardware. So, yes, that was what I was doing. Basic plan for the series for replication is step 1, demonstrate an XOR. Step 1, demonstrate the basic mechanics. Step 2, demonstrate an XOR gate. Step 3, demonstrate a 7-segment display. And step 4, demonstrate a counter counting from 0 to 9 on that 7-segment display. Always doing it in scrap mechanicallys first, and then doing it in this logic. And it's 20 minutes in, and I only get to that now. So, has anyone commented on Twitter? Is there a Twitter that I care about? There's no Twitter that I care about. But this is still live on my channel, which is really weird. Fine. Oh, I need to change the description. So, this is the basic gate. As you can see, I've got a loop, and the way I have the 4-bar loop is by anchoring this in all 3 dimensions. It's really ugly, I know. I don't care. Aesthetics is not part of the design document. Aesthetics is not part of the design document. Keep telling yourself that. Now, we have to do this again. And the thing is, we have to do this again, but it must grow organically from the system, right? So that's the whole point, is that we have a single point of contact, which, by virtue of being the single point of contact and having everything else anchored to itself, should provide the mechanism. So now going back here, right? This is again Molecular Mechanical Computing Systems by Merkel, Freitas, Hogg, Moore, Moses, and Riley, published 5 days ago, 2016. This is their research. This is what I'm doing is only replication. I think replication is an important part of science, but none of what I'm contributing is innovative. I absolutely recommend their paper, and I'll just enhance. imm.org/reports will get you this paper. So, what we just did is a figure 1 4-bar linkage that is bistable in left-leaning and right-leaning. And it's this sentence, right? Links are simply stiff, beam-like structures. Rotary joints are joints that allow for rotational movement in a single plane. That sentence made me go, aha, I can do this in Scrap Mechanic. I should probably buy the game. Which is what I'm doing. So, we have accomplished this in Scrap Mechanic. We have shown that this indicates two states. That's what we care about. Now we're doing the lock. So, I need to stare at this for a moment. Actually, what I need to do is I need to do a new window. And I need to put this where I can see it. And then click, click. So, in case of anyone chatting at me in the stream, please chat at me. Oh dear. Please chat at me. Anyways, so I've got the design up. This is I'm trying to implement figure 5. Let's see how it goes. So, nope. Sorry. Scroll. Excellent. All right. How are we doing this? We are pulling. So, the reason why this is so exciting is because this is very much. Oh, they have this going the other direction. So the anchoring links are on this side. See, this is why you look. This is why you look. And then. How do we do this? We go 2, 3, 4, 5. Yeah. And put that down. I think I have to do this while disconnected. So what we do first is we lock this in place. It does help if one, okay, so go click, oh, whoops, click. Actually, I don't even think we need to do that. So we want that to be rotated towards the blue 30 degrees. Sure. And then two, 3. And, I'm quite aware that a competent computer engineer could do this much more quickly and much more professionally. So they probably should. 30 degrees. Okay, so the problem is that this needs to be friction fit. This needs to be friction fit in such a way that this pattern holds. So doing the rotation is not going to work because this requires a loop, right? Because the whole point of the exercise is that this is in the 0, 0 position. And then we have that go to the 0, 1 position. And so the states of 0, 1 and 1, 0 are what we care about. But my hypothesis, so is there a reason why we need this connecting triangle? So I think we're going to erase all of these. Erase all of these. Now, let's get some painting going. Cute. Yeah, painting. The trick with painting is that one must use the paint tool to paint. Shocker, I know. 1, cute, and so 1, 2, 3, 4, 5, 6, 7, cute, black. 1, 2, 3, 4, 5, 6, 7. So the point that we need to anchor is half and half. So I have to make this one less. How can I friction fit a bar here? And is it worth? Actually, it is worth doing, and I know how I can do it. So really? No, because the connecting link won't be stable in reset mode. So whatever we do must be stable in this mode. Which means I have to redo this work. So, discovery. It must be odd. Oh well. How many of you saw that coming? Oops. So go blip and then Q, and we make the center bit red. Yes. Put it on the lift. Put the lift over there. Drop on here. So 1, 2, 5, 6, 7. And so the point is we are always growing organically from the same structure. And by growing organically from the same structure, we retain the necessary linkages of the thing. Come on. Okay. So again, this worked when there were the balance issues, but then failed to work. And actually, we can get this pattern more betterist by locking it into what amounts to a sponge. And again, always, 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 always do a thing. Test. Do a thing and test. Stable in one direction, stable in the other direction, and it is stable. Yay! Okay. So, we cannot therefore, in order to make... No, we cannot make this stable without using controllers, which means we're not going to go with this method to start with, because the only controllers I want in this system are input and output controllers, and of course, the internal resetters. But I don't want any of this to be governed. So, therefore, I want this to extend out 4, 5, 6, 7, and lesson always have a center point. Always have a center point. Then Q. No, and then green 1, 3, and 7. 1, 2, 3, 4, 5, 6, 7. Okay. And a thing, and it's a new thing. So what do we do to new things? That's right, we test them. Yep. All right. Viable so far. Now, so the purpose of the lock is that if one is at... Purpose of the lock is that if one is at 1, or if one is in right leaning, then the 1-1 state is not possible. So the test is that 1-1 is not possible, and the starting state is 0-0. So we must be able to prove that both inputs cannot be set to 1-1 at the same time. So this is in 0 because it is in the center. Extra super centered stuff. Coherency is overrated. I'm a philosopher. I just said that in a recording, didn't I? Mm-hmm. Good job, me. And that's green. There we go. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Q. Black. 2, 3, 4, 5, 6, 7. Q. White. 1, 2, 3, 4, 5, 6, 7. Okay, so good so far. And free bearing. Only 29 cents. No. Because if this comes back. No, I thought about that. 2, 6, 7. Alright, yeah, no. This is everything is fine. Everything is perfectly fine. 1 error. 1, 2, 3, 4, 5, 6. Two, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. As one of my characters is wont to say, poop. Because, as a scatological expletive, it is neither profane nor blasphemous, and is therefore useful when one wants to express frustrations without being overly offensive. Okay. 1, 2, 3, 4, 5, and 6, and this is going to be 1, 2, 3, 1, 2, 3, 4, 5, 6. You know what? Yep, and because we can visually differentiate 3s, but right. Alright, so 1. Nope. But we can do this on all of the bits. So 1, 2. Okay, reds. Q. 1, 2, 3. 4. Yep. 2, 3, and 4. 1, 2, 3. 2, 3, 4. 1, 2, 3. error, 1, 2, error, 3, and error, 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 4. Q and pink, 4, and red, 2, 3, good, and yay, good job, good job. Hey, someone's very briefly watching. People who are watching say hello, so I'm not just shouting in the void. 2, 3. 3, and 4. 3, 4. So, does this look the same? 1, 2, 3, 1, 2, 3. Yep, 1, 2, 3, 1, 2, 3. Yep. And those are long. Alright. This is someone's flag. I'm sure it's someone's flag. Everything's someone's flag, except for New Zealand. It would be very hard to make the New Zealand flag, or the Australian flag. Okay, then flip, flip, flip. Oh, what was that clank? Ah. Oh, dear. So the point of the exercise is we have a central member coming up like so. And we have 3, 4, 5. Nope. We have locking members coming down like so. It would be so awesome if this worked. Right. And lift goes down. Lift goes down to hold. Ah. Okay, well that's an issue. That is a problem, but I do not anticipate it being a significant problem. And so one thing I've learned from Scrap Mechanic. Yep. So one thing I've learned from watching many people play Scrap Mechanic is that the block's attached where the cursor is pointed. So we must be very mindful of that fact. When making these Menger sponges. Filled in Menger sponges, or in other words, a bloody stupid solid. Locked. No. Oh. Okay. So, I mean, this is not intended to be a Let's Play for entertainment, although hopefully my blithering is at least not repulsive. I'll settle for not repulsive. Ooh, 3 people are watching. Woohoo! Doot and doot and doot 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 and doot and then doot. Probably don't need these end caps, but frankly, optimization has never been a concern. Getting it to work is the concern. And So, hypothesis is that this is going to be a functioning balance. Testing the hypothesis is clank. Okay, that is off. So I should be able to set this into 1. Okay. No. Because this is rigid, and so this needs to allow poop. Okay. Oh, this is so tedious because need to find a better way of anchoring. Need to. All right. Take a sip. Problem. Now, of course, the welding tool isn't out yet, so the easy way of doing this isn't. But I wanted to do this now, so my problems, as ever, are my own design. Because we can test this without building this whole section up. Which means that we in fact shouldn't have built this whole section out. Now, the trick is that we need... Alright, let us see if a short connector in the middle will perform what we need it to perform. 1, 2, 3. All right, so that's 3 and 4. 3, 2, 3, 4. Now, requirement is that this be anchored, and if this is anchored, then this is demonstrating the system at 0 without me needing to build out the whole bloody thing. Actually, I don't think we need all that much anchoring. See, this is why engineering is also a challenge. And yes, it should be really obvious right now that I'm a philosopher trying to engineer. All right. So, this is rigid. Huh. Oh, don't act all innocent. I know what you've done. If we don't need this much armoring, what could possibly go wrong? I don't know. What could possibly go wrong? You tell us, game. I know, block physics. Block physics could go wrong. So that goes off. I hereby declare that joint not to be a load-bearing joint. But if we hit this, it not a load-bearing joint. It's fine. It's not perfect system. So this should be able to move like so, and like so, without this being unduly discomforted. Yes. Pull onto this stop. Yep. And then pull onto this stop. Now, actually, this gives me an idea. Yay. Okay, so reset. This, ladies and gentlemen, is why we have Mr. Locke, because stay. So, hypothesis is that this thing I has a sensor, and then I has a horn. So if we put the sensor here, and the horn there, and link, and link. Really? Ah, yes. Okay, then turn that off. And then so we know that this is achieved honk when it, in fact, honks. And then we go the same here. Except so high pitched, low pitched. All right. Auditory feedback is good. This link is valid. Therefore, if instead of this monstrosity and clank, so I'm certainly not saying that for a simple XOR gate this is viable. I wouldn't use this in scrap mechanic until they have the welding tool, or until obviously they have loops. If they have loops, all of this becomes, well, very straightforward. Oh no, paint your colors, paint your colors, paint your colors, paint your colors. So 1, 2, 3, 4. 1, 2, 3, and down, and then we go. See, this is why we have colors. 3 and 3, 6. 1, 2, 3. 1, 2, 3. 1, 2, 3. 2, 3. Black, And what did I just paint? Alright. Valid? Yep, valid. And test. Always test. Beep. Okay. Underbar goes up. This 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 3 and 4. The important thing here is symmetry now. Therefore, if these are stable in exactly the same way, this is going to be at 0, which means we can test and because we can test, we will, in fact, test, because we can. See? But I'm not going to anchor these too deeply in, which I know I'm going to regret, but that's an awful lot of block. So let's just see. So this shouldn't be able to move. Doesn't move. This should be able to honk and tweak. Honk. And tweak. And this is static. Huh. Not honestly expecting this to have worked. So, therefore, we can remove that. That falls through. Remove that, and that falls through. And then we can go hee 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 hee. And hee 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 hee. Oh, I'm so not getting dinner tonight, am I? Twitter. Hey, Twitter. Twitter is twittering. Twitter is suspended. Tab is suspended. Well, that's good. And notifications are none whatsoever. That was a hope. So, we go clickety clackety. Put in a bearing. So, and then this is a friction stop. 1, 2, 3. 1, 2. And it's a friction stop. I'm so glad I did this on the lift. This would have, well, it wouldn't have worked gravity-wise. And the friction stop is necessary because we don't want these things moving out of true. I'm not sure how critical it is, but well. Now, I think I'm going to need a resetter on this as well, but test, always test, always test, always test. It goes off, and then this goes off. Bonk. Alright. So, because this system must always be able to return to 0, 0, the system must always be able to return to 0, 0. And this is all part of the same system. towards the red. Towards the red. You know what? That needs to be on the other side. Always test. Always test. Always test. Always test. And then we have the I button, which is none of the buttons that you just pushed. There. And the I button goes here. So. That's out of true because that's not fixed, which means we cannot. Well, actually, we can test it. It's just not going to be useful. Yeah. Error. Fine. Fine. What we expected. What we expected. So, now we bring that down. And what we have learned in this process is that 2, 3, and down, additional anchoring is indeed desirable. So what is what? Wait, yes, we want it to go towards the red. I think what we learned is that Brian's an idiot. Yes, Brian is indeed an idiot. Locked in 0, 0. So obviously that needs to be, so it's a little bit elastic, but it works. And then those lock. Excellent. And with bracing, it might even work. 2, 3. That's not where most of the stress is going to be, but there's going to be a huge amount of horizontal stress. So all right. I'm going to be so annoyed if I have to build this again. Well, I mean, here, I mean. All right, so here's the test. Step 1. Does that work? Yes. Good. Step 2. Does this... This is in 0, 1. That's in 0, negative 1. Now, the trick is that this should not be possible. And it's possible even with So it'd be really nice if anyone had any ideas. Okay. This magic energy from nowhere. Fine. Whatever. Okay. So the same length and same angle. Therefore, the center link must be 7, because these are 7. And it can't rotate around the center, it has to rotate around the edges. Fine. Everything is fine. Everything is fine. Oh god. No. Everything is fine. 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 So, we know that a triangle can be instead, this whole thing go away, go away, go away. Go away, I say, go away, I say, go away, go away, go away, go. Be off with you. Infernal thing. No? Alright, well, fine. Be that way. Alright, so we know that a triangle can be decomposed into horizontal and vertical members. So instead of having the joint here, the angle of those change. So we can do this with L-shaped pieces. We are so not even getting to the balance today. Does this still work? Yep. All right. So, critically, it is. I've been going for an hour and 10 minutes. There's been a whole bunch of random crap. Fuck it. Alright, so click and click. Now. How does this work? Okay, we have 1, 2, 3, 4. 1, 2. 3, 4, 5, 6. That's in the red zone, which is for loading and unloading of passengers only, no parking. There. And then one, two, three, 4, 5, 6, 7. You, shush. Now, is there a functional difference between... Oh, this must rotate. That's fine. This can rotate. Yes. So, but that's going to slide. That's fine, because we can prevent sliding by having it be interlocking. Like so. Click. No, we want to protect against slides. So and so because of where it is located on this axle, it is an incredibly inelegant solution, but okay. Does this still rotate? So, stable one way, stable the other way. That just rotates back and forth because there's nothing to lock it to. But if we then so what they assert is that the connecting link is the same length as the side links, which means this must be 7. 6, 7. Prove it, Brian. and then yes, so this is then the center connecting link, which is 7 long. 1, 2, 3. Ah, no, this is not going to work because it will require the center point is there, which means this needs to be down 1. I'm going to set an alarm for the bus. I am going to stop the stream in 7 minutes because I'm hungry and I want to have dinner. And, you know, no one's watching, so everything is wonderful. Okay. Clink. See, we're learning. We're learning. So. 5. And 7. Yes. And then, so we can test this by being in, okay, so this is like so, this is equivalent to a diagonal, but critically does not require a diagonal. So then we have this coming out. 1, 2, 3, 4, 5, 6, 7. 3, 1, 2, 3. 1 Q yellow. Yep. All right. 5. 1, 2, 3. 1, 2, 3. So yellow falls in the middle. Okay. And that means that if this is anchored, then this should behave as if this lock is in 0 state. Does not need to be anchored well. Fine. So. Click. Oh, well. Correct. This cannot move. Therefore, this behavior is correct. See, by recording my journal, everyone else can laugh at my mistakes too. And somehow, I thought this would be a good idea. Now, what we really meant to do, see, I was just testing you, viewer after the fact. I was just testing you. is we go there, 2, 3, 4, 3, and simple loop. So that what? So this is representing the other lock at 0 state. Which, well, don't know what happened. Do it again. So blip and blip and blip and blip. Millennium Hand and Shrimp, anyone? See, you know, I'm actually really glad I tested this before I built ever anything more, because that would have just been tedious. This isn't tedious, Brian. Why would you say that the endless rebuilding is tedious? I'm glad you asked that. Anyways, alright. So central anchor, anchor up. And so we need this side because otherwise it's going to flail about madly. That's fine. 3, 4, 5, 6, 7. 1, 2, 3. 3. And black. Alright. And then so so oh, I'm not actually sure we need this link. Oh yeah. No, we need this link because if this goes this way, this will just rotate out without a link there. Yeah. But let me get away. This can we get away with murder? I'll have you know, it is no crime to be an idiot. Blip. This does not rotate. This is not happy. So it's rotating there instead of there. That means, nope, that's not going to work. That is not going to work. This is not a triangle. because the point of the rotation is in fact at the point of rotation. Shocking, I know, right? Like, who would have guessed that the point of rotation occurs at the point of rotation? It's like, oh my god, right? 5. Now, this is aligned for now. I do not trust myself. Huh. Apparently. Yeah, it worked. Alright. Okay, so. Everything is loop in this. Everything is loop in this. Everything is loop in this. Okay. So this is a point of rotation that must be therefore fit. Meh. Epicycles. Everything is epicycles. Okay, and then that just goes down. Alright, I'm going to go right up and say that I am not doing a 7 segment. If I can get an XOR gate to work using this complicated method, I think I will be sufficiently chuffed, because help, 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 help. Alright, so that should be locked. Bit heavy, but, and so therefore these have that, and there's like that. Which means that alright. And then this is the same balance as that is. Cool. So, I'll probably be back Friday doing this. Please comment on more innovative ways of doing loops. That would be super awesome. So this is anchored at 0. If this is anchored at 1, then it could not move because we're following the instructions. Alright, so this has been Brian Dawson Stanton in Let's Scientifically Replicate Molecular Mechanical Computing Systems by Merkel, Freitas, Hogg, Moore, Moses, and Riley. out of the IMM report number 46 from April 2016. Their design is copyright them. I'm just here trying to reproduce it in a thing. Well, I will thank everyone for watching this hour-and-a-half stream. Hopefully it was interesting. Until next time, something. Yeah, something.